Hello everyone, I Sandeep Bhatt, Assistant Professor, Department of Electronics and Telecommunication, Runta College of Engineering and Technology, Bhilai, affiliated to Chhattisgarh Swami Vivekananda Technical University, CSVT, Bhilai. Welcome you, course on Fundamental of Communication and its application. Today's our topic of discussion is noise, external noise, internal noise, noise figure and signal to noise ratio. The objective of this lecture is there are four objectives. The first one is the basic concept of noise, the nature of noise and characteristics of noise. Here we will discuss about fundamental of noise. The second objective, the type of noise, and here we will see the different types of noises. The third objective is noise figure. This is one of the important factor in noise that we will discuss in detail. The fourth objective is signal to noise ratio. Here we will learn the relation between signal and noise. Now, let us start with the definition of noise. What exactly noise? The unwanted signal are referred to as a noise. The signal which we don't want. Now, let us take a real-time example. Suppose you are in traffic and you got a call from someone. What you are experiencing here? You will not able to listen the voice from your mobile clearly. So, what exactly happening here? The background audible signal break the clarity of audio signal. This background sound is nothing but the noise. Noise in the context of communication and signal processing refer to any unwanted or unintended disturbance that obscure or interferes with the intended signal. This disturbance can degrade the quality and clarity of the information being transmitted, making noise a critical factor to manage in the various fields such as telecommunication, audio engineering and broadcasting. Noise is an unwanted signal that can disturb electronic circuits and communication system. It can degrade signal quality, cause data transmission errors and affect system performance. Now, why one should know this noise and why to study about noise as an engineer? The understanding the nature of noise is crucial for mitigating its negative effect on communication system. By studying noise, we can develop strategies to minimize its impact and enhance the quality of system. To understand the basic noise with deeply, one should know the sources of noise, that is, from where it is generated and what are the causes. Sources of noise that can comes from variety of sources, generally classed as man-made noise, natural and internal system noise sources. Let us discuss one by one in detail. The first one is man-made noise. This form of noise is caused by human activity and includes sound from industrial process, transportation system such as car, train, aeroplane, motors and domestic appliances. Power cable, ignition systems also contribute to man-made noise. We can quote more examples here where system is made by the man. The second one is natural noise. But obvious, natural means the environmental sound such as thunderstorm, volcanic eruption and insects or birds and other creatures all produce noise that we cannot change, or we don't have such kind of, we cannot control or such kind of noises. The natural occurrence such as solar flares and cosmic backgrounds radiation also fall within this category. The third one is internal system noise. This noise originated within electronic system and includes thermal noise due to random motion of electrons, short noise that is caused by the fluctuation in the current, and flicker noise, that is the low frequency noise found in electronics devices. This type of noise can degrade the performance of communication system and electronics devices. Understanding the sources of noise is crucial for developing strategies to mitigate their effect. Ensuring better performance of communication and electronic system. Now, we have confirmed that the sources of noises. Now, let us explore the more about noise with their types. The types of noises for the noise in a communication system can be classified into two main categories: external noise and internal noise. Now, let us discuss or more explore about what exactly external noise. The external noise is generated outside the communication system, can be natural or man-made, hindering effective communications and can be measured qualitatively. Understanding the reducing external noise is critical to integrity and efficiency of the communication system. External noise is split again in three main categories, that is, the first one is atmospheric noise, second one is industrial noise, third one is extraterrestrial noise. Now, we are going to further explore external noise in detail. The atmospheric noise, that is also known as static noise, is a natural disturbance in the communication system caused by atmospheric phenomena. Preliminary lightning discharge in the thunderstorm. Its random, erratic nature can interfere with signal transmission and reception in radio and other communication systems. It is random and broadband. These disturbances occur in the form of impulses, and because of their random nature, they spread over an entire radio spectrum. This noise is less of at 30 MHz because higher frequency to limit to line of sight transmission less than 80 km. It is created at VHF range. VHF means very high frequency range. The field strength of atmospheric noise signal is approximately inversely proportional to the frequency. Atmospheric noise is unpredictable and can vary in intensity. It is more noticeable at lower frequencies, making it significant concern for long distance radio communications, especially in amplitude modulation bands. Now, we can quote here a best example, that is, if you are listening the radio signals or any channel through amplitude modulation and suddenly the lightning happens, that causes the audio disturbance or disturb signal during the signal. Even if you are listening the radio in your home and if you use or at the same time is something happening naturally in that particular band, you will be able to listen that sound through amplitude modulation. So, this noise can cause error or disturbance in the transmitted information, leading to degradation in quality of received signal. Effective communication system must incorporate noise mitigation techniques to minimize this effect. This noise can produce error or distortion in the broadcast information, reducing quality of the signals, received signal to mitigate the consequences. The effective communication systems must employ noise mitigation strategy. Atmospheric noise management is crucial for enhancing the reliability and efficiency of communication system, especially in areas prone to thunderstorm and other atmospheric disturbances. Now, come with the next type of noise, that is extraterrestrial noise. This comes from outside the Earth atmosphere, including solar noise, that is from the sun, and cosmic noise from the distance of stars and galaxies. Extraterrestrial noise exists on the basis of their originating sources. These type of noise are again subdivided into two parts, that is solar noise and cosmic noise. Now, let us discuss about what exactly solar noise. But obviously, solar noise means it came from solar. Solar noise arises from sun. It has constant noise radiation from the sun. The solar cycle repeats every 11 years, which disturb the electrical signal with the peak value. Every 11 years, solar cycle change their peak values. Now, the solar noise can have a significant impact on communication system, particularly in satellite communication and radio frequency communication. Here, a detailed breakdown of effects of solar noise and communications are: the first one is electromagnetic interference. What exactly electromagnetic interference? Solar noise, also known as the solar radiation emissions, generates electromagnetic interference that can disturb the communication signal. These emissions primarily affect the radio frequency bands and can result in signal degradation of loss. Due to solar noise, even there is a change in signals during the daytime when the sun rays are available on the earth. The second one is satellite communication, where we find the impact of this noise. Solar noise can cause the changes of satellite communication system, particularly those operating in higher frequencies. The noise can affect the quality of received signal, leading to the decreases in the signal to noise ratio and potentially impacting overall reliability of satellite links. Solar noise can cause absorption of radio waves in the Earth atmosphere, especially during the period of increased solar activity. This can lead to signal attenuation. This solar noise morely affect on electrical signal. Then second one we have the cosmic noise. Cosmic noise, also known as extraterrestrial noise, referred to natural background radiation originating from various sources in outer space. This noise arises from astronomical phenomena and celestial bodies across the universe. Now, the galactic sources are the cosmic noise can originate from our galaxy, the Milky Ways and other galaxies. This noise can come from pulsars, supernova remnants and other astrophysical objects emitting the radiation across the electromagnetic spectrum. Extragalactic sources are beyond the galaxy. Cosmic noise can come from the quasars, active galactic nuclei and cosmic microwave background radiation, among other sources. Now, let us discuss the frequency spectrum of these noises and sources. Cosmic noise cover a wide frequency spectrum ranging from very low frequency like radio waves to higher frequencies like gamma rays. Different astronomical sources emits radiation at specific frequencies, contributing to the overall cosmic noise observed. Impact on communication, if we see here, in communication system, cosmic noise can affect signal quality and transmission reliability, especially in radio, astronomy and deep space communication. Understanding and mitigating cosmic noise are essential for processing and interpreting weak signals from space. Now, let us discuss about the characteristics of cosmic noise. Cosmic noise exhibits random fluctuation and variation due to dynamic nature of celestial sources. The intensity and characteristics of cosmic noise can vary depending on the frequency bands and observation time. Now, let us discuss about the man-made noise. They originate from human activity like industrial operations, electrical equipment and vehicular traffic. It is generated from sources such as automotive engine, machines, aircraft ignition, electric motors, switching gears, leakage from high voltage transmission lines and other heavy machines. It also called a man-made noise having frequency range between 1 to 600 MHz. Any system or any kind of the machines or objects that is made by man, and if it is generating any such kind of noise, will be covered in a man-made noise. What are the key sources of this? The key sources and aspect of noise includes, the first source is industrial activity. This is one of the best example for man-made noise. The equipments and machineries used in factories and construction produce significant noise. Then second one is transportation system. Noise from vehicles, airplane, trains contribute heavy to man-made noise pollution. Even when we pick horns, this is also the sound pollution under the transportation. The third one is telecommunication equipments or devices such as antenna, other electronic equipments can generate electromagnetic noise interfering with the radio and communication signals. Here are again two types of noise. One is the internal noise and another is the external noise. Some noise we can hear in audible range, some noise we cannot hear, that is not in audible range. The next one is everyday activities. The sound from activities such as finger tapping, footstep making and other personal activities also contribute to the man-made noise. Again, let us discuss about what are the types of noises. The impulsive noise is a sudden and sharp sound which can be man-made or natural. Then second one is a continuous noise. It persistent noise from constant sources like running machineries and traffic. Now what exactly internal noise? Internal noise is a type of noise produced internally within the communication system or by the receiver. They may be dealt qualitatively and decrease or minimize by effective system design. Internal noise can be categorized as thermal noise, short noise and transit time noise. Now let us discuss about the detail of internal noise. The first one is thermal noise. What exactly thermal noise? Thermal noise is random and is also known as white noise or Johnson noise. Thermal noise is typically seen in the resistor or sensitive resistor components of complex impedance due to random and fast movement of molecules, atoms or electrons. The noise is frequency independent, that is white noise is a frequency independent and can be qualitatively represented using the Johnson's-Nyquist criteria equation, where this Vrms value is equal to under root of 4k TRB, where K is the Boltzmann constant, T is the absolute temperature in Kelvin, R is the resistance in ohm and B is the system bandwidth in Hertz. It is also observed that thermal noise contain all frequencies in equal amount. That is why it referred as a white or Johnson noise. Now second one is the short noise. Short noise is a phenomena where DC current pass through a potential barrier such as PN junction. It is independent of temperature and it produced by random arrival of charge carrier across the barrier. The noise intensity is proportional to the number of electrons passing through the wire at the given time. The short noise is given by, that is I, equal to under root of 2q I suffix p b, where I is the RMS short noise current, q is the electronic charge, that is 1.6 into 10 to the power minus 19 coulombs. I suffix p is the direct diode current, B is the bandwidth of system. So by using this different the key factors, we can calculate the short noise. If we talk about the frequency component, it is contained frequency up to 100 megahertz. The third one is transit time noise. Transit time noise is a type of noise in transistor which occurs when carries moves from input to output. The devices are tiny, so the distance involved are minimum. At low frequencies, this time is negligible. However, when frequencies of operation is high, the signal processing is the same as the transit time. Problem can occur. This time noise appear as random noise within the device, directly proportional to the frequency of operation. The periodic time of the signal is equal to reciprocal of the signal frequency. When the signal frequency is high, periodic time becomes very small and hence may be comparable to transit time of carriers. In such case, sum of carriers come back to emitter. Due to this, conductance of input component increases with frequency. This conductance has associated with a noise current generator. Since the conductance increases with frequency, the noise spectrum density increases at high frequency. There are other sources in active devices may be classified as a miscellaneous noise, but we are not exploring more here, we are just introducing what are those. The first one is flicker noise, second one is the partition noise, third one is the resistance noise. Now, this is the first part of noise where we had to discuss the sources of noise, the types of noise, their characteristics, their importance, their limitations, right. Now, the second part of this presentation is noise factor. This is the one of the important factor in a communication while we design a system, and we calculate every time, and we always keep in mind this noise factor must be within limit. So, what exactly this noise factor? Let us know more about it. The noise factor F of an amplifier or any other network is defined as, that is, noise factor F equal to available signal to noise power ratio at the input N by S available S by N power ratio at the output. Since the amplifier or network under consideration will always add noise, the signal to noise ratio at the output will always be less than that at the input. The noise factor F then will always be greater than unity. So, this is one of the main key factor here. Noise factor F will always be greater than unity, it means 1. The noise factor gives an indication of noise added by the circuit for which noise factor is calculated. In many cases, the noise factor depend upon the frequency and it is calculated and can be at one single frequency, where it is known as a spot noise factor. An average value of noise factor can be calculated over a given frequency range. This gives an average noise factor that is called as a F average. Here we will discuss only spot noise factor, assuming that frequency known. The second one is, once you know what exactly the noise factor, now we discuss the noise figure. If the noise factor is expressed in decibel, it is known as noise figure. For the circuit, thus noise figure equal to 10 log of F, where F is the noise factor. Now, if we understand the system is ideal and there is no resistance in the system, the factor is 1, the noise figure will be 10 log of 1, that is equal to 0 dB. For improvement of the noise figure of a receiver, the active devices used in the radio receivers should have low noise. In this respect, diodes and FETs are more reliable for mitigating this problem. Also, to reduce the thermal noise and receiver operated at low temperature. The principle is followed in the receiver used in the satellite communication. Here the main factor is, if you want to be the noise figure within the limit, one should have the strategy. We use the semiconductor devices in the receiver, that is diode and FETs. FET is a field effect transistor. So, we use these two devices, electronic devices at the receiver to manage this noise figure at the receiver. Now, once we know that the what exactly noise figure and the noise factor, now come to the point that last objective of this system or this lecture is signal to noise ratio. This is one of the important factor in communication. Everywhere you can have analog communication, digital communications. Every engineer is more will find is what exactly he will calculate most of the times the signal to noise ratio. It is very critical to maintain this signal to noise ratio. Noise is typically expressed as a power, as received signal is also expressed in terms of power. The signal to noise ratio can be computed by knowing the signal to noise power, typically expressed in decibels. The ratio of desired information or signal strength to the unwanted signal or background noise is known as a signal to noise ratio, or we call it as a SNR. So, SNR is equal to signal power upon noise power, that is P suffix s by P suffix n. P suffix s is defined is nothing but a signal power and suffix n is nothing but a noise power. What exactly importance of this signal to noise ratio in communication system? SNR is crucial in determining the quality and reliability of signal. A higher signal to noise ratio indicates a better quality signal and vice versa. Now, how to express the value of SNR? SNR can be expressed in logarithmic decibel scale, that is called as dB, where higher values represent a better signal to noise relationship. So, this relationship is very important. Now, let us see what exactly and what trade-off is there. Trade-off means if you find here one signal or one value may increase, the other value get decrease, right? This is nothing but a trade-off. So, we are finding here the trade-off. Increasing SNR often required more power or bandwidth. So, this is the trade-off. If you want to increase the power or increase the noise ratio, the bandwidth will be increases or power will be increases. So, the trade-off between achieving higher SNR and the resources need to do so. Now, this is what about we have done all the sources of noise, concept of noise, type of noise. Now, we need to conclude this lecture. Now, right from the first of beginning, we have learned here what exactly noise, the characteristics of noise, nature of noise, and how to understand this noise and where this noise gets effect, whether internally, externally or in between. So, we can conclude here noise is always interfered through the channel, maybe at the system, maybe outside the system, at the receiver, at the transmitter. We also discussed the effect of noises and how to mitigate this effect. The noise is random in nature, it can be reduced but cannot be completed eliminated, right. So, we can reduce it, but we cannot completely eliminate the drawback of noise. Signal to noise ratio, this power is the figure of merit of any electronic circuits. The ratio should be high as high possible and can be improved by addition of radio frequency amplifier in the circuit. So, this is one of the key point how to manage the S by N ratio. So, we can use the any RF amplifier before mixer. The high performance electronic systems are needed for variety of applications including data transmission, audio engineering and telecommunication. These systems must be designed and maintained with an awareness of ability to manage both internal and external noise, as well as for maximizing the noise figure and SNR. This is what about the complete of noise, their sources, their types, their impact and everything. So thank you very much for listening this lecture. Thank you.